Hi, this is Mr. Miller again, and this is video 11E. In this video, we'll be proving some polynomial identities. All right, let's get going. So, first of all, I want to explain briefly what an identity is. An identity is an equation that is always true, no matter what values the variables have. For example, we have the identity x squared minus y squared equals x minus y times x plus y. I think this will be one that you prove at some point, but no matter what values for x and y you put in here, this is true. For instance, I could say 10 squared minus 7 squared equals, well, 10 minus 7 times 10 plus 7. Okay, on this side it's 100 minus 49, which is 51. And on this side, we would have 3 times 17, which is 51 also. So no matter what values I pick for x and y, this equation is true. That's an identity. At the other extreme is a contradiction. A contradiction is an equation that is never true. For instance, like x equals x plus 1. If you think about that, it's saying a number is equal to the same thing as 1 plus that number. That's never true. That's a contradiction. All right. Well, our job is to show that certain polynomial identities are true. All right. So we're supposed to prove, this means demonstrate it's true, this polynomial identity, that x plus y quantity squared equals this. Now, the way we prove this is to start with one side and show that it's really equal to the other side. I'm going to start with this side. It's usually easier to multiply things out. So I'm going to multiply this and show that this is what we get. So x plus y quantity squared is what you get when you multiply x plus y times itself. Okay, I'm going to use the box method here to kind of see what's going on. I have x plus y here and x plus y there. X times x is x squared. X times y is, well, xy. Y times x is the same thing. I'm going to write it as xy though. And y times y is y squared. Okay, when I add these up, we get x squared plus xy plus another xy plus y squared. All right, well, these are like terms. We can combine those. And what we get is x squared plus 2xy. xy plus xy is 2xy plus y squared. So we did it. We started with x plus y squared, and we ended up with this. We show that it's true. Now, we're going to use it to find 7 plus 3 quantity squared. Well, that's 10 squared. We know that's 100, but we're going to use the identity to get 100. So this is x is 7, and y is 3. So we have x plus y squared. And that's supposed to equal to x squared, 7 squared, plus 2xy, plus y squared, which would be 3 squared. So all I did is substitute 7 for x and 3 for y into the right side here. And we get 49 plus, that's 14 times 3 is 42, plus 3 squared is 9, and sure enough, that equals 100. Yeah, this is true for any values of the variable. We are just using the values 7 and 3. Okay, in this example, we're going to prove the famous difference of cubes formula. We have one variable cubed minus another variable cubed. And this identity shows us how we can rewrite this as a product. Quantity x minus y times that polynomial. All right, just like before, it's easier to start with multiplication. So I'm going to start with this right side, and I'm going to show that when we multiply this, we end up with the left side. So I'm going to put x here minus y, and here I'm going to put x squared plus xy plus y squared. All right, so when we multiply, x times x squared is x to the third power. X times xy, well, that's x squared times y. X times y squared is just that. Minus y times x squared, I'm going to put the x first, so that's minus x squared y. And we have minus y times xy is minus xy squared. And minus y times y squared is minus y cubed. So we have to add all of these up. So here we go. We get x cubed plus x squared y plus xy squared minus x squared y minus xy squared minus y to the third. All right, we have 6 terms, but 4 of them are going to cancel. Take a look. So here we have x squared y, and here we have a minus x squared y. Those cancel. And here we have xy squared, and here we have a minus xy squared. Those cancel. So we're just left with x to the third minus y cubed. So all of this is equal to x to the third minus y to the third, which is what we're supposed to show. We multiplied these two things and we ended up with x cubed minus y cubed. Now, we're supposed to use this to rewrite this. Well, x cubed plus 64 is the same as x cubed plus 4 cubed. Well, now we're supposed to use it. We're supposed to rewrite x cubed, this should say minus 64 as a product. Okay, so this is x cubed minus 4 cubed. 64 is 4 to the third power. So here we have our difference of cubes. X is playing itself, and y is equal to 4. So we could rewrite this as x minus y, that'd be x minus 4, times x squared, plus xy, that'd be x times 4, that'd be plus 4x, and y squared, that'd be 4 squared plus 16. So we proved the identity, and there we used it to write x cubed minus 64 as a product of x minus 4 and that polynomial. Wow, that's pretty abstract. We can do this though. Good luck.